All right, everybody, it's Coach Lowe back with you. Unit 2, Designing Experiments. Got to warn you, I'm now on sinus medication, so anything can happen. Moving on to the next screen. Here we go. Let's get to it. All right, a lot of vocabulary that we got to keep straight here for experiments. All right, so experiment deliberately imposes. An experiment deliberately imposes treatments on individuals to measure their response. Very important. Treatment, the actual treatment is what each individual is assigned to do. Control is what condition is exactly the same in each trial, except for treatments compared. So these are things that you want to control all the extra variables as well. Like you want to make sure they had the same breakfast, same temperature, same conditions. That way you can sort of isolate anything that might be important, any kind of change. Explanatory variable, should say here, is what is deliberately changed to see if the change causes a response variable. And then the response variable, of course, is going to be measuring the outcome. And slightly different is an observational study, and that's just a study that uses already available data and it does not impose a treatment. So there will be quizzes and tests later, and you'll have to decide whether something is observational study or an experiment, and that's pretty much it right here. Whether does it impose a treatment or not? So if there is a treatment involved, then you're going to experiment. If not, it's probably observational. All right, next screen. A little bit more. The subjects of an experiment are going to be those receiving the treatment. All right. And then you got blind and double blind. So if a subject does not know which treatment they are getting, then that's considered a blind experiment. And then it's double blind if neither the subject nor those collecting the data know what that treatment is. So you got blind and double blind. Here we go. Like that. All right, so example. So does creating a distracting atmosphere affect players' performance on free throws? Man, wouldn't you like to get some numbers on this? So let's say you got the crazies right behind the basket. Does that influence the results? So here we go. A treatment. We're going to assign half of the players to shoot free throws in a distracted environment, and we're going to get the other half to shoot in a distracted free environment. Okay, so we're just going to split it right down the middle. Half are doing this, half are doing that. Okay, that's your treatment. You're assigning what everybody's going to be doing. Control, things you might want to think about. Make sure the ball is the same size. Make sure it's the same distance, same location. So that's all the things that you want to be the same. Explanatory. So this is what you're actually changing in an experiment. So in this case, we are changing the environment. So we're going from a distracted environment, lots of crazies running around trying to distract you, versus a quiet, all right, distractful free environment. And then, of course, response is going to be easy to measure, miss or make for the shot. So that's a good example. All right, good example, observational study. So let's say you just go into a game and you're going to take into account how many strikes a pitcher throws after the count is 3-1. So they're looking for that next pitch. So you're just recording the data and you're analyzing it to make a decision about the pressure of pitching. So you're sort of using data that's already there. You're just taking it all in. That's observational. And again, there was no treatment imposed. Next screen. It's a little wild and free with the ink. All right, here we go. Is it experimental or observational? So in a study, a group of mice are given an injection of a drug proposed to shrink lung tumors. After 1 month, the tumor sizes are measured. So would this be experimental or observational? So since you're actually imposing a treatment, you got a group of mice that are going to be given a certain injection. That is a treatment. So I'm just going to write that right here. Got a little lag. Holy cow, what is going on here? All right, so since you got a treatment, that means this one's going to be an experiment. So Bob proposed that the more you exercise, the more likely you are to be promoted at your job. So he reviews the exercise regimens of co-workers who were promoted and those who were not. So he's he's not imposing a treatment on anybody. He's just going out and he's getting the data. So that's observational. Okay, Peter records the reactions of everyone in a movie theater during the ending of the end game. So again, you're just taking it all in. You're not imposing a treatment. That's observation. All right, here we go. Coca-Cola. So does caffeine increase pulse rate? A statistics class with 20 students, and now it's about the time you want to start looking at details here. Let's scale this down a notch. Let's go orange. All right, so let's highlight a student statistics class. We got 20 students. Design an experiment to find out. Half of the students were randomly assigned to drink caffeine or cola with caffeine, and the other half were assigned to drink caffeine-free cola. Before the students consumed their beverage, they measured their initial pulse rates. Then, 10 minutes after finishing their beverage, they measured their pulse rates again. So they calculated that change in pulse rates. So right off the bat, is an experiment observational? Since they're imposing this treatment, it's definitely going to be an experiment. Okay. So they're definitely imposing a treatment. All right, so what is that treatment? So here you have to assign what is everybody doing here. So we have 20 students in the class total. We're going to half that. So we got 10 students doing what? So I'm going to write this down here. We got 10 students that are going to be drinking cola with caffeine. So they're getting the caffeine. And we also have 10 students that are going to be getting no caffeine. Okay. Also, I'll put this right over here. I don't want to miss this out. You're going to get their pulse 10 minutes before. Yeah. We got standards. Yeah. All right. So 10 minutes before. Come back. All right. So we're getting pulse 10 minutes before. And then we're going to get 10 minutes after. Squeezing all that in there. All right. So that's basically your treatment. And then you're going to calculate, of course, pulse rates. Or the change, excuse me. Actually, you know what? I think I'll leave that out. Let's go back here. Well, still struggling. All right, so moving down to the next item. Okay, so controls. What would be some controls for this? 10 students, you're going to get their pulse rates, and then 10 minutes after that, you're going to be throwing some colas at them. Some of them get the caffeine, some of them don't. And then 10 minutes after that, you're going to be doing another pulse rate. But what could we use to control this? So thing is, you got different body types. So I would try to do similar body types because caffeine affects different people differently. But you can also think about what kind of food they have before that. I mean, did everybody have the same breakfast? All right. What about night? That sleep the night before, all that kind of good stuff. So there's a lot of things you want to think about. You want to make sure everybody's on the same page as close as you can before you run this experiment. All right, explanatory. So what are you actually changing? And that's going to be cola with caffeine. Cola with caffeine. And then, could this be blind? So could you put these in like little cups and distribute it to your students and then they not know which one's which? Absolutely. All right. And for that matter, you could run it as double blind. Okay. Hang on, let me just see here. They measured and have students assigned. It doesn't actually specify that they did do this blind, but definitely it could be yes. All right. And for that matter, it could be double blind possibly. All right. Last example. Here we go. Glad. So, do name brand trash bags hold more weight than store brand trash bags? Trash bags. Two statistics students, Janelle and Brittany, decided to test it out. So to do so, they randomly selected 15 Glad trash bags, 15 Walmart trash bags, loaded them down with oranges until they broke. So, first things first, is this going to be experiment or observational? Since we are imposing this treatment, all right, we got 15 bags here, 15 bags there. We're going to load them up and see what happens. That's definitely going to be an experiment. Again, because we are imposing a treatment. Hopefully no animals get hurt. All right, so what is the treatment? So we're going to take 15 bags or 15 Glad bags. We're going to take 15 Walmart bags. And then basically we're going to load them down. We're going to add oranges. All right, I guess you know what? I like that a little better. Let me do that. Change the wording right there. If you let me. Come on, medium eraser. There we go. So we're going to basically add oranges until the bag breaks. Okay. And all right, so that's your treatment. Controls, what we want to do? Not all oranges are the same. Let's try to get the same size oranges, maybe. Same size oranges. And it could be little things too. You're going to set them in there. You're going to throw them in there. I'm assuming we're just going to be adding one at a time. So we'll just keep it right here. Control, same size oranges. We're not going to get into barometer or anything else like that. Okay, so explanatory. So what are we changing? We're just changing the bag. Changing the type of bag. And then response is going to be, just going to assume how many oranges. We'll measure this by oranges. How many oranges does it take? And then blind. Could this be blind? So if you take them out of the box and somebody just throws a bag at you, can you tell which one it is? So I think definitely yes, possibly. Okay. All right. So that is just a little bit with experimental, a couple of good examples. And that's it. So good luck.